Hello everyone. In the previous video we were discussing about page replacement algorithms and we discussed about first in first out, that is FIFO page replacement algorithm with its example. Today we are going to discuss about optimal page replacement algorithm. As the name suggests, optimal page replacement, that means this is the best algorithm, optimal algorithm, which gives the maximum throughput with minimum number of page faults in the execution system of the processes. So this is the best algorithm to use for replacement of pages with the lesser number of page faults so as to improve the efficiency of the system. So this is the algorithm which has lowest page fault rate of all the algorithms, and it is also free from Baladi's anomaly that we have discussed earlier. Also, when we talk about optimal page replacement, so it tells about replacing the page that will not be used for longest period of time. That means we will look into the future reference of the string of the pages. The string of the pages that we will be replacing in the example, we will look forward from the page that is required to be replaced in the future string, that which page will be will not be required for the longest period of time. That page will be the victim and will be replaced by the desired page into the system. That means it requires future knowledge of the reference string. Whatever the reference string is there to be referenced for replacement of pages for execution of processes, we must know in advance the future reference string, that which page in future will be required to be replaced. It is also used for comparison studies in the system. So let's have an example for optimal page replacement algorithm. We are having the same string as we have discussed in the first in first out page replacement algorithm. In FIFO, we encountered with 15 page faults. Now let's proceed and check that how many page faults we obtain in optimal page replacement algorithm. As we have studied about it, it will be producing the least number of page faults in the system so as to provide best results. So let's proceed. So simply first three frames, we have three frames in the frame set, and this is the string. So we will start replacing the pages one by one. So first we'll put 7 into the empty frame, then we'll put 0 into the empty frame, then we'll put 1 into the next empty frame. Now all the frames are occupied. Now next comes page 2. Then we will have to replace the page into the frame set. So first we will check if it is already existing, then the page is not already existing into the frame set. So we will check that from the 7, 0 and 1, which page will not be used for longest in the future. So from 2 onwards, we will look into the future string, this 0304230321201701. When we will check the whole string in the future list, we find out that page number 7 is the page that will be used at last. Yani that the page number 7 will not be required for longest among the page number 7, 0 and 1. So page number 7 will be replaced with page number 2. and the frame set becomes page number 2, 0 and 1 occupied. Then comes 0, which is already available in the frame set. Then comes 3. Then again we will check for page number 2, 0 and 1 in the future string. Then 0 is instantly being used. Then comes 4, then comes 2, and then comes 3. Then 0, then 3, then 2, then 1. From this we identified that page number 1 is the longest that will be used at later stage. So we will replace the page 1 with the page 3, and thus frame set now having page number 2, 0 and 3. Then page comes 0, which is already available, so no page fault. Then comes page 4. Now we again check the future string for page 2, 0 and 3. 2 is instantly being used, then 3 is instantly being used, and then 0 is being used. So 0 is the longest to be used, will require longest time to be used. That means it will be used later than page number 2 and 3. So page number 0 will be replaced with page number 4, and the string frame set has page number 2, 4 and 3. Then comes page number 2, which is already available, no page fault. Then comes page 3, which is already available, no page fault. Then comes page 0, not available, so we'll check the future string for page 2, 4 and 3. Then 3 is being instantly used, 2 is being used, so 4 is the page that will not be used for longest. So we will replace page number 4 with page 0, and the frame set now has page 2, 0 and 3. Then comes page 3, which is already available, so no page fault. Then comes page 2, which is already available in frame set, so no page fault. Then comes page 1, so we check the future list for page 2, 0 and 3 that will not be used for longest. So page 2 is instantly being used, page 0 is being instantly used, so we will replace the page 3 with page 1, as it is the page that will not be used for longest. Now the frame set has page 2, page 0 and page 1. Then comes page 2, which is already available, no page fault. Then comes 0, which is already available, no page fault. Then comes page 1, which is already available, so no page fault. Then comes page 7. So we check for page 2, 0 and 1 in the future string. And 0 is being used instantly, 1 is being used. So we will replace the page 2 with the page number 7, and the string now has page number 7, 0 and 1. Then comes page 0, which is already available, so no page fault. Then comes page 1, which is already available, so no page fault, and we have completely processed our page string. So now we calculate the total number of page faults that occurred in the optimal page replacement, that is 1, 2, 3, 4, 5, 6, 7, 8 and 9. So total number of page faults in the optimal page replacement algorithm is 9. And earlier we discussed FIFO algorithm, which was having the page fault of 15. Page fault rate was 15 in FIFO. With the same string, optimal page replacement produces page fault rate of 9. So it is the best algorithm among all, and we till now we have studied FIFO and optimal page replacement. In both the algorithms, optimal page replacement is better algorithm than FIFO algorithm. So this is all about optimal page replacement algorithm. In the next video, we will be discussing about least recently used page replacement algorithm. Thank you very much.